class, welcome to Unit 1, Graphs of Linear Functions. In this series, I'm going to try to deliver you these three main points of content. So the first is I want us to know how to graph linear functions. The second is I want us to know how to write the equation of a linear function from the graph of a line. And the third is that I would like us to be able to write the equation of a line parallel or perpendicular to a given line. So those are our three learning outcomes. That's what we're going to try to do in this video. I encourage you to take notes as we go. I encourage you to pause the video if you need to, rewind, listen to another section, whatever you need to do. We're going to start off with the first point. We're going to start off with graphing linear functions. So we're going to do this first. There are two methods that I'm going to teach you for this topic. And for some of you, this may be review. Enjoy. Some of you, this might be brand new, or maybe you learned this 20 years ago in high school. Don't worry, you got it. So method one that we're going to use is plotting points. And method two that we're going to use is about using your y-intercept and your slope. And if you don't know what those are, don't worry. I will show you. So here we are. I'm going to start us off with method one, plotting points. And this will be a nice chance for us to review a little bit of function notation. So here's the example we're going to work with. Here is a linear function, f of x is equal to negative 2/3 x plus 5. So this that I pronounced f of x is function notation. And so what you can think of here is that this x and this x are the same value. They're the input value of the function. So for example, if I'm trying to plot points, what that means is I'm taking values of x and I'm plugging them in to the function and solving for values of y. So here is our x. And when I say values of y, that y is equal to f of x, the output, after I put in my x value. So we're going to plot points and make a table here, and that's going to help us review our function notation, and then we'll be able to use these points to graph a line. So I know that most students don't really enjoy fractions, and I'm hoping in this class that you'll learn at least not to be afraid of them. You don't have to like them. I don't really like them all the time either, but we don't have to be afraid of them. So I want to call your attention to the denominator there, 3. I'm going to show you a trick that will help us to do some calculations that'll make our lives easier with that fraction. When I choose input values, when I choose values of x to input here, I'm going to choose multiples of 3 here. Multiples of 3 are numbers like 3, 6, 9, 12, and so on. And I'm also going to choose positive and negative values because that'll give me a more complete picture of the line. So for my x values, I'm going to choose negative 6, negative 3, 0, 3, and 6. And so what I'm going to do is I'm going to do these first two values, negative 6 and negative 3 for you. Then I'm going to encourage you to pause the video and work on the others. And then when you start the video again, you'll be able to see me fill in those blanks. So if I'm choosing negative 6 to plug into my function, the way I would write that is I would say f of negative 6. This is my input. And I plug that in everywhere that I saw an x value. So it's here and here. And then I simplify this output. So I have negative 2 over 3. Negative 6 is also a fraction. I can write that as negative 6 over 1 plus 5. And then with fractions, I multiply the numerators together to get my new numerator and the denominators together to get my denominator. That's what happens when you multiply fractions. So a negative 2 and a negative 6 gives me positive 12. And then a positive 3 and a positive 1 gives me positive 3. So now I have 12 over 3 plus 5. But notice here, this divides evenly. 12 divided by 3 is equal to 4. So now I have 4 plus 5. And that gives me 9. So by choosing a multiple of 3 for this function, I was able to get a nice number out, number 9. And I'll follow along. We'll do that again. We'll plug in negative 3 this time. Then I'm going to encourage you to pause the video and try a couple calculations on your own. So f of negative 3 is negative 2/3 times negative 3 plus 5. Just like before, I have negative 2 over 3 times negative 3 over 1 plus 5. That gives me a positive 6 divided by 3 plus 5. I have a negative times a negative, so that gives me positive. And then I'll end up with 2 plus 5, aka 7. All right. So then that's how I'm plugging in points. And if you're graphing the line, you really only need at least 2 points. So if you were doing a problem like this on the homework, you could stop here and plot those 2 points and be done with it. I want to make a point, so I'm going to show you something a little bit further than that. So what I would like you to do is pause the video and try 1 or 2 of these values here. And when you start the video back up, you'll see me fill in those answers. Go ahead and pause. All right, so welcome back to my good, diligent students who are ready to check your answers. And hello to everybody who's on the bus or too busy to do that right now or just not feeling it. It's okay. I'll show you what we get anyway. So if you plug in 0, your output will be 5. If you plug in 3, your output will be 3. And if you plug in 6, your output will be 1. I'm going to erase this work to the side here because I have a point to make. And I want to graph this line. Goodness gracious, we ought to graph this line. I'll plot those points for us, and you'll be able to see the line take shape, and it'll be beautiful. It'll be beautiful. All right, so now I've got a little bit of room to work. I apologize, I'm sure you can hear my dog in the background. I'm sure at some point during this semester you'll hear my baby. You'll hear all kinds of things happening here in my home. That's the fun of working and learning from home. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just getting my boxes together, making myself a beautiful X and Y axis. I wish it was prettier. But I'm still getting used to this iPad, even though I've been working on it for a semester now. All right. So we're going to plug in these points here. So we have the point negative 6, 2, 4, 6, positive 9 here. We have the point negative 3, positive 7 right here. And this is my, I really should label these nicely. If you guys turned in a graph like that, I'd be so mad. This is my x-axis. I should do it nicely for you. And this is my y-axis. If I plug in the point 0, I get out the point 5. If I plug in the x value of 3, I get out the y value of 3. And if I plug in the x value of 6, I get out the y value of 1. And we can see this line taking shape with these points here. This is our line. And then, of course, I'm going to draw arrows on the end here to show that this line actually continues. I could plug in as many points as I wanted. This line has infinitely many points. So here's our x and y axis. So that's how you would graph a line, plotting points. And I want to point, something out to you. that's going to help us in the next step of graphing lines. There's a pattern here when you look at your x and y values. So take a look at your x values. Here I'm circling in red. And your green values, your output values, your y values, I'm circling in green. So in x, each time we go 3 units to the right, here, right? I started at my point, my x value was -6 for this point, and then I added 3 units to the right for an x value of -3 here. So I'm always adding 3 to my x value. And as I do that, as I increase x by 3, something happens to my y value. And the same thing happens every time. I'm subtracting 2. So as x increases by 3, y decreases by 2. And that's actually going to teach us a little bit about how to find the slope. Some of you might remember that, and that's going to help us in the next part when we graph a line using the y-intercept and the slope. So that was graphing lines by plotting points. And now I'm going to show you guys how to graph a line by using the y-intercept and slope. So I'll point that out actually on this line so you can see it. I'm going to highlight it in white. This point here is what we would call the y-intercept. Because it touches the y-axis. It touches the y-axis. So let's discuss method 2. Graphing a line using x and y intercepts. Oh, not x and y intercepts, excuse me. Using slope and y intercepts. So for this, we're going to need to know what the slope is. The slope, you could think of it as measuring steepness or measuring change. As we move on to calculus, we're going to talk about it more and more in terms of change. So for slope, we use the letter M. M almost always recognizes slope. And I told you before, we could call this the change. We would say it's the change in y divided by the change in x. A very advanced math notation way of saying that is to draw this little triangle here. That is a delta, and it means change. So this means the same thing as this, but it's in math notation. So now we have our delta y over delta x, or you might have seen this formula, I hope, in your algebra course, y2 minus y1 divided by x2 minus x1, where x1, y1, and x2, y2 are just points on your line. So that's our slope. But what about the y-intercept? You're mostly going to be doing this when you have, I'm going to show you an example that'll help. So here's our example. F of x is equal to 1/2 x plus 1. So this equation is in what we call the slope-intercept form. Of f of x equals mx plus b. So here, m is your slope. So in our example, the slope will be 1/2. And B here, our y-intercept is 0, comma B is the y-intercept. So that means that the y-intercept of our line here will be 0, comma 1. So let's go ahead and graph this. You start off by plotting your y-intercept. Start off by drawing your x and y axis, actually. Here's my cute little x and y axis, and I'll even label it for you. Here's my x-axis and my y-axis. And my point 0, comma 1 is my y-intercept. And I know my slope is equal to 1/2. You might have seen this as your rise over your run, your change in y over your change in x. So I know that y will increase by 1 and run, my x will increase by 2. So that means I can go up 1 and over 2, as your algebra teachers are fond of saying. And I can do that again if I like. Here's something kind of clever. I can also go down 1 and to the left 2. That would be -1 divided by -2. But a negative divided by a negative is a positive. So that would be equivalent. And that would be our line. This is a lot easier to me than plotting points. It's just kind of like drawing. But, you know, to each their own. And that's how you graph a line. Those are both methods for graphing a line that we're going to do. In the next video, I'm going to show you how to write the equation for a function from the graph. And we're going to talk a little bit in the following video after that about parallel and perpendicular lines. Thanks for watching, and I hope you have a good day and you enjoy some math today.